we have a new section to do. And we're going to do this one today. And we did manage to finish with this the other class, so I'm pretty comfortable that we'll get this section done today. It is called L'Hopital's rule, or L'Hospital's rule. And he's a Belgian, I believe so. But clever guy. He came up with this very niche market thing. L'Hopital's rule says that if you have two functions, f and g of x, and they are what's called indeterminate form at some number x equals a, if you want to find the limit as x tends to a of f of x over g of x, right? So you're basically going to find the limit of a fraction. He discovered that this limit was the same answer as the limit of the derivatives of those. So it's not the quotient rule. Do you notice I'm differentiating the top and bottom totally separate? Now, when we use the word or the words indeterminate form, what we mean is that the top and the bottom are both zero, or the top and the bottom are both infinite. So these are what we are. So L'Hopital's rule allows us to find the limit of fractions by finding the same limit of their derivatives. It's impressive that that's true, but it is. Let's show you how it works. Let's suppose I'd like to find the limit of x to the power of 1,000, take away 1, divided by x minus 1. Now, if I gave you that question to do in week 1, remember when we did limits? I think it was week 1. The only technique that you would be able to use would be factor and cancel. If you evaluate that, when x is 1, isn't 1 take away 1 0 on the top and 1 take away 1 0 on the bottom? You have 0 over a 0, right? What's called indeterminate form. Now, do you want to factor x to the power of 1,000 minus 1? And the answer is no, I do not want to try and factor that. Can you just imagine how hard it is to factor? I doubt if I'd have enough room in this one piece of paper to write the answer, even if I could do it. But L'Hopital, and you write an equals and a little L above it to tell everybody you're using L'Hopital, says that I don't need to find this guy's limit. Because it's 0 on the top and 0 on the bottom indeterminate form, I can use L'Hopital, and he says, differentiate the top and differentiate the bottom. Now I'll find the limit. Well, 1,000 times, well, 1 to the power of 999 is just 1 over 1, and the answer is 1,000. It's kind of almost like magic. Horrible question, can't do, turned into really easy question, got the answer. Suppose I want to find the limit as x tends to 3 of x minus 3 over x squared minus 9. Now, in week 1, wouldn't we do factor and cancel? Right. So let's do factor and cancel just to show you what the answer is. And then we'll do L'Hopital and see if it works. So if you use the factor and cancel method, you factor x squared minus 9 as a difference of 2 squares. You cancel the x minus 3s. You can then plug in 3, and there is your answer. Right, that's week 1 technique, right? That works pretty good. Let's try L'Hopital on it. Well, just double check. 3 gets you 0 in the top, 3 gets you 0 in the bottom, indeterminate form. So I'll use L'Hopital. So it's the limit as x tends to 3. If you differentiate x minus 3, you get 1. If you differentiate x squared minus 9, you get 2x. You can then plug in 3. And from a totally different road, don't you get the right answer? It's a 6. There's a lot of difference between these two, but I think this is a little bit easy. Factoring is not always easy, especially when the guy you're trying to factor is a horrendously ugly thing. Then L'Hopital wins hands down. So L'Hopital is kind of your go-to technique. If I want to find the limit of, a fraction, like something divided by something, if I want to do that, I would probably use L'Hopital 9 times out of 10. Not every time, as you're going to find out, but the vast majority of the time. Well, let me pick some new guys. Let's do this fella. Let's do the limit as x tends to pi upon 4 of cosine x take away sine x all over tan x take away 1. Right, cosine of pi upon 4 is root 2 upon 2. Take away a root 2 upon 2, so the top is 0. The tan of pi upon 4 is 1. 1 take away 1 is 0. It says indeterminate form. That means I can use L'Hopital. If you differentiate a cosine, you get a negative sign. If you differentiate a negative sign, you get a negative cosine. What do you get if you differentiate a tan? See if you lot can be quicker than the other class. Derivative of, yes, well done. Now I'll bring it over here because I need some room. It's going to be negative the sine of pi upon 4. Take away the cosine of pi upon 4, all divided by the secant of pi upon 4 squared. I'm just writing it that way to emphasize what that means. Okay, this is going to test your knowledge. What is the sine of pi upon 4? What number is the sine of pi upon 4?
The square root of 2 over 2.
Okay, so this is negative square root of 2 over 2, and so is this one. That's good. Not really one I would expect you to know off the top of your head, but we still need to find its value. Let's find the secant of pi upon 4. Right, the way I would tackle this question is I would find 1 over the cosine of pi upon 4. Because isn't a secant 1 over the guy? Well, that would be... Say again?
Square root of 2?
It is. It's a square root of 2. I'll show you where it comes from. So it's 1 over a cosine, which is root 2 over 2, which is basically a reciprocal. You then make it look pretty. And you get root 2. Oh, but then you square it. Negative a half root 2, take away another negative a half root 2, just gets you that guy. And square root of 2 times itself gets you 2, and there is your answer. Before L'Hopital figured out this lovely little rule of his, this little formula, whatever you want to call it, there was no real technique that we had for finding limits like this. Can you imagine week 1, if I had gave you that, you couldn't have done it by algebra. I guess the best you could have done would be like a table of values and just pick numbers closer and closer to pi upon 4 and see if some answer came out. But since this answer isn't a nice number like -1/2, wouldn't it be quite hard to know what it is? Actually, it's -0.707. Oh, come on, you should be impressed by that. You're not impressed, are you? If you have done enough trig in your life, you start recognizing certain decimals. 1.414. Who's he?
I have written out
Square root of 2. Right. I won't go into the other ones, but you know, like √3/2 and all those kind of guys that tend to turn up in trig, you recognize their decimal version. So that sometimes if you're not sure of an answer, but you see a decimal version of what you think it is, you can then say, wait a minute, that's probably √2, or that's √2/2, or that's √3/2, you know, one of the standard ratios that come up a lot in trig. And that gives you a kind of insight into what it would be. But that's a different story. So let's say do a polynomial. The limit as x tends to 2 of x cubed take away 8 over x squared take away 4. Now, if you plug in 2, you get nothing over nothing, so that's indeterminate form. I'll do L'Hopital on it then. It's the limit as x tends to 2 of 3x squared over 2x. That should be what? 3 lots of 2 squared over 2 lots of 2. That should be 12/4. Okay, the answer is 3. You can also use L'Hopital's rule for fractions where the limit is x tends to infinity. Take that as an example. Now, if you plug in infinity, would you agree you get infinity on the top over infinity on the bottom, right? So it still counts as indeterminate. And according to L'Hopital, you can find the limit then as x tends to infinity of the derivative of the top guy and the derivative of the bottom guy. And if you plug infinity here and infinity here, you get, you get infinity over infinity. Oh, I guess L'Hopital doesn't work all the time. And then you pause and you say, wait a minute, isn't this just indeterminate form? Can't I just use L'Hopital on it? And the answer is yes. So in other words, you can use L'Hopital repeatedly until you get the answer. So it's now going to be the limit as x tends to infinity of differentiate the top and differentiate the bottom. And there's your answer. Isn't that cool? You can do it for x tends to 2 or 0 or infinity. L'Hopital doesn't care. As long as it's indeterminate form, things work out really nice. Let's try a guy like 15. The limit as t tends to 0 of 9 to the t, take away 5 to the t over t. Okay, if you plug in 0, 9 to the 0 is 1, take away 5 to the 0 is 1, 1 take away 1 is 0 on the top and 0 on the bottom. It's indeterminate form. That means we can use L'Hopital on it then. Okay, this will bring a little cobweb thing going on here. We have done them. What is the derivative of 9 to the power of t?
Natural log of 9 times 9 to the t.
Correct. And the other one is natural log of 5 times 5 to the t. What I'm now going to do is plug in 0 and see what we get. We get log 9 times 9 to the 0. Take away natural log of 5 times 5 to the 0 over 1, so I won't worry with that. That's 1. And so is that one. And then just to make it look pretty, there is your answer. Now, before L'Hopital figured out his lovely little rule, if I asked you to find the limit of this, would you agree that there's no algebraic way of factoring and cancelling? Wouldn't you just have to do the best you could, which would be a numerical estimate? But now we have a perfect answer, right? That's the exact answer. And it's relatively simple to do. Now, hopefully you've noticed that as I've been doing these questions, I've been checking that it is indeterminate form, right? Before I did it. Because we are now going to look at some situations where you could be caught out. Here's our first one. Oh, worse. I tried this reference with my other class and only one student got it. So here goes. Danger, Will Robinson. Danger. Sabrina, do you want to tell the others where that comes from?
There might be more people who get it now. There was a reboot of Lost in Space.
Lost in Space, exactly. The old series, but I'm not sure in the new series because I've never watched the new series. But I doubt if the robot ever says that in the new series. Right, so danger, Will Robinson. We are about to enter some dangerous questions. So you are going to be on tiptoes here, because if you're not careful, you're going to get them wrong. Here is question number 1 that has a problem. I want to find the limit as x tends to 2 of that fraction. One of the ways you can find a limit is called evaluate. In other words, you just plug in 2. If you get an answer, that's a limit. And this one works. Because you get 8/7. Now, imagine I got this question, and I'm just so hell-bent on every time you see a fraction, it's L'Hopital. And I use L'Hopital. Do you think I should get 8/7 as an answer? You would think you should. Let's find out. Danger, Will Robinson. L'Hopital does not work if it's not in indeterminate form. You know, I keep saying it, right? 0 over 0, infinity over infinity. Every question, 0 over 0, infinity over infinity. If that's true, L'Hopital will work. If you plug in the numbers here, don't you not get 0 over 0? Don't you get 8/7? So it's worse than, well, I just did some extra work, but I got the answer, so there's no biggie. It's worse than that. If you do it when you shouldn't, you get an answer, but isn't it just the wrong answer? That's worse than, well, I got the right answer, it just took me twice as long, right? That's not a biggie, right? So rule number 1, a very important rule, is always check that your fraction is in indeterminate form. That means that the top number is 0 and the bottom is 0, or the top is infinity and the bottom is infinity. If neither of those situations are true, whatever method you're going to use, do not use L'Hopital, right? Just keep away from it. You know Murphy's Law, you'll do 10 questions and you check 9 of them. And so you get lazy and you don't check the 10th one. Isn't it the 10th one the only one that you should have checked because it wasn't L'Hopital's rule? Now, I don't know because I should have checked, and maybe I'll go back and do it, to deliberately put one of those questions in. Right? Like one of the homework questions might well be this. I hope WebAssign did this. It's typical in textbooks, that they will put questions in where you shouldn't use L'Hopital's rule, right? Like this. Just to get you, to force you in a way to check every single time. So that's the first danger, Will Robinson. Here is the next one. Now, this question is a little bit different from this one. In this one here, you just don't use L'Hopital's rule, right? It doesn't work. This question here is a little bit more subtle. It is indeterminate form, or at least it better be. Yeah, it's 0 in the top, 0 in the bottom. So technically speaking, you could use L'Hopital's rule here. Not saying you couldn't. You could use it. But you know my rule, just because you can doesn't mean you should rule. Remember, I've used that rule a few times. Sometimes it's just not a good idea to use L'Hopital. Not because it doesn't work, but can you imagine how ugly those two guys are going to look like when you differentiate? Now, if I wanted to do overkill, I could probably put a square root in the bottom just to make it even uglier, right? It's probably a good idea to use the conjugate method. So whenever I see square roots in one of these questions, I tend to think maybe I should be using the conjugate method because it's probably going to come out a lot nicer. I'll show you an example of that right now because I'm looking at it. If I can, there we go. I have no idea where my window is right now. Let me try again. Right, are you looking at question 16 now? Right. Can you see that ugly square root guy? Can you trust me that mathematically it's less work to do the conjugate method? You're just going to trust me on that. But I mean, if you want to fight your way through L'Hopital, go ahead. It's not like you won't get the right answer. You probably just won't like the math that you'll need to do to get to that right answer. Right? So there are a couple of the things to watch out for. L'Hopital does a really good job, but it is a niche market, right? It finds the limits of fractions by finding the limits of their derivatives, but it can only work when they're in indeterminate form. Any questions about that before we do some more examples? Are we good? Right. Try this one then. If you plug in 0, isn't the sign of 0, 0, and 0 in the bottom is 0, so yeah, we're good to go. Now, if you differentiate this fella, use L'Hopital's rule, you will get the limit as x tends to 0 of cosine x on the top and 1 on the bottom. And now I can plug in x is 0, and I get the answer 1. Before L'Hopital was around, do you know how hard it would be to find the limit of sine x over x? What I want to show you now is kind of a visual proof that this is working. So I'm going to go to, if I can find it. I know you're in here somewhere. Stop hiding. Desmos, there we go. Okay, where's Desmos? I've lost you. I got you back. Okay. So I will move over and hopefully show you Desmos. And we are going to verify that the answer is in fact 1. So y equals sin x over x. There we go. Can you see that as x approaches 0, isn't the answer 1? Started doing something here. Wish I'd thought of this earlier. I just wanted to see what the reciprocal looked like. It's still 1, but it approaches in a different way. Can I go? Yeah, how about this guy? Let's see if we can adjust L'Hopital's rule to work for situations that it wasn't really designed to work for. Suppose I'd like to find out what the limit as x tends to infinity of x sine of 1 over x is. Well, I got a problem here. It's not a fraction, so I can't use L'Hopital. So first thing I'm going to do is make it a fraction. Now, it's kind of artificial, but it works. Isn't x the same as 1 over x? That makes sense? Now, it's a fraction. So if I plug infinity in, isn't the sine of 1 over infinity the sine of 0? And the sine of 0 is 0. And isn't 1 over infinity 0? So I have a 0 on the top and I have a 0 on the bottom. So it is indeterminate form. So that means I can use L'Hopital on it. So I will. I will differentiate the sine of 1 over x. Wow. If you differentiate the sine of 1 over x, you get the cosine of 1 over x times the derivative of 1 over x, which is negative 1 over x squared. And on the bottom, I will differentiate 1 over x, and you can trust me, but you get negative 1 over x squared. Now, this guy cancels out that guy. So what I now have is the limit as x tends to infinity of just the cosine of 1 over x. Well, that's the cosine of 1 over infinity, which is the cosine of 0. and the cosine of 0 is 1. Okay, I got it. It's now in WebAssign, and I'm going to prove to you that the limit of x, the sine of 1 over x, is 1. Right, now here's the function. Can you see it? If I shoot along to the right here, would you agree that that is leveling off at 1? Does it help if I do it that way, maybe? Have I convinced you that, as unlikely as it seems, finding the limit of the derivatives is the same as getting the limit of the original function? So we now have a very powerful tool, but it only does one job. It finds the limit of a fraction, right? You don't use it for other, weird things. And you can sometimes, if you're really sneaky, you can adapt it to take care of these guys. I think that's pretty cool. Now, let's see if I can find where our questions are. Okay, now let's show you L'Hopital rule with weird answers. I need weird answers, so that is going to be this one. Okay. And I use L'Hopital on this. By the way, this is question 13. I'm getting a deafening silence here. Should I be able to use L'Hopital on this question?
Yes.
Okay. What is the natural log of 0? Well, if you look at the natural log, isn't that negative infinity? Is this indeterminate form? Is it a 0 over a 0 or an infinity over an infinity? No. In fact, it's one of these two guys down at the bottom. 0 over infinity is not indeterminate form, so don't use L'Hopital. It's equal to 0. And infinity over 0 is an indeterminate form. The answer is either infinity, right, or does not exist. So this question is 1 out of 10, right? Remember we said there's 1 out of 10 that you shouldn't use? You got to figure this guy out in some other way. And the way they phrase it in the question says this: find the limit, use L'Hopital's rule where appropriate. If there is a more elementary method, consider it. I'm not sure what they mean by elementary. How about plug it into WebAssign and just plug it into Desmos and look at it? Wouldn't that be useful? That would work. So I'll let you figure that one out. How about the limit as x tends to infinity of the square root of x over 5 plus e to the x? Well, if you plug in infinity, that's infinity. If you plug in infinity, that's infinity. It's definitely indeterminate form. I know it's got a square root. I did say when you see square roots, will you use the conjugate method? I should have been a little bit more specific. If it's a square root, like the square root of x plus 2, take away 4, you know, that kind of square root look. And this one here is totally okay to use L'Hopital on. So it's going to be the limit as x tends to infinity. If you call that x to the half, if you differentiate it, you get this. And this guy here, you get that. And what causes a problem with this one is that you have to do a fair amount of style points. Are you happy about this line becoming that line, or do you want to see the step that belongs in the middle? Can you see that the half becomes a 2 in the bottom, and the negative a half becomes a square root in the bottom? Are you happy about this becomes that? Right, let's plug infinity in then. 2 times the square root infinity, e to the infinity, 1 over infinity, the answer is 0. Are we okay with that question? Just a little bit different. It's still L'Hopital, but you have to, you know, you have to deal with unusual circumstances. I think there's a double one here that I want to do, if I can find it. And that one. Let's just look at the questions. That might give me an idea. Right, here's this fella. Just checking your time. Look at question 6. I'll make them bigger. Yeah. Question 6, I can do using L'Hopital, and it will work. I'm not arguing. It's not one of those situations where, you know, you can use it and you get the wrong answer. And the reason it will work is, isn't it 0 over 0? Right, so it's indeterminate form. Is there a different technique I would probably want to use on this one? What would that other technique be?
You can look at the bottom as a difference of 2 squares and then cancel.
That would be correct if the top was x minus 7. But it's the square root of x minus 7. Are
Yeah,
you correct? That would work. How about doing a conjugate first and then what you just said?
Wait, but
So-
the bottom is just an x, so you'd have to take the square root of
Oh
both.
God, I take that back. You are right, Matthew. I take that back. I saw the bottom is x squared and it's not x squared. Totally right. That is sneaky and good. I like that. That was not the way I was thinking, but that would work perfectly. I was just going to do the conjugate, which also would have worked. You would have got the answer 1/14 in both cases. Nothing really weird with that one, nothing weird with that one, nothing weird with that one. We'll keep them for the last few minutes. Done that. I think we pretty much, oh, I'll look at that one. It's definitely L'Hopital. I don't think there's a lot you need to worry about there. I guess the only mistake you might make, and I hope you wouldn't, if you differentiate the sine of x minus 1, don't you just get the cosine of x minus 1? That's it. That one works totally fine. Pretty standard. Done that one. Done that one. I would definitely use conjugate on that one. Question 17. You would end up, I think, having to do L'Hopital 3 times before you got the answer. but eventually you would get the answer. In this question, 18, you'd have to do L'Hopital twice before you got the answer, but you would get an answer. In this question, you'd have to do L'Hopital twice, but you would get an answer. Oh, the last one, and then I can show you the top questions. The last question, so it's perfect. The limit as x tends to 0 of the inverse sine of x over 4x. So let's do L'Hopital on it. And I am allowed to, because the inverse sine of 0 is 0 and 4 lots of 0 are 0. So L'Hopital is good to go. Uh-oh. The derivative of an inverse sine function. That one is a sneaky one, because we spent about 10 minutes on it. So somewhere you've written it down, and if you're really good, you've actually memorized it. What is the derivative of an inverse sine function?
1 over square root 1 minus x squared.
Impressive. Unless you were reading it off a piece of paper. But that's still pretty good because it means you had it handy. Did you just memorize that one, Jesse?
No, I have a note card.
Yeah. Aren't note cards very helpful things to have, right?
Definitely. I have a
Especially-
bunch taped to my monitor. It helps a lot.
Right. So a big circle of, yeah, top right-hand corner, bottom left. Good idea. Right, in this case here, I can now plug in 0. It's the square root of 1 times nothing squared over 4, which is 1 over 4, and there's your answer. So I am now about, I'm just going to do it on the paper. I was going to show you it on the screen, but it's easier if I do it this way. I want you to look at some special, well, make it A. Won't need to do it that way. Got a quicker way of doing it. 0 over 0 is indeterminate form. Infinity over infinity is indeterminate form. I'm now going to show you some other calculations. And you won't be able to use them directly in L'Hopital, but they still get labeled as indeterminate form sometimes. And our job is to find out which ones are indeterminate form and which ones we know the answer to. So I'll give you one I know the answer to. That guy is not indeterminate form. That guy is 0. Agreed? 5 over infinity is 0. 2 over infinity is 0. Isn't 0 over infinity really, really 0? Right? It's an extra special version of 0, if you like. But what about this fella? Is that indeterminate form? Indeterminate form means it's got an answer, but we just don't know what it is. That's not the same as does not exist. Does not exist means there is no answer to find, right? Is this indeterminate form or not? It is, isn't it? Now, some of you might be thinking the answer is 0. And good, because you shook your head at the right point. Not 0. And the reason why it's not 0 is that you are thinking of infinity in the way you think of normal numbers, right? 7 take away 7, right? 5 take away 5. Infinity can't be regarded that way. Infinity is not a specific value. It's an idea of infinitely big. So here's an analogy for you. Would you agree that there's an infinite number of whole numbers? would you also agree that there's an infinite number of fractions? If I went and said to you, take all the fractions in the world and subtract all the whole numbers in the world, you could call that infinity take away infinity, couldn't you? So far, so good. Now, let's think about fractions for a minute. Between 0 and 1, isn't there an infinite number of fractions? A half, a third, a quarter, a fifth. Between 1 and 2, isn't there an infinite number of fractions? Isn't the whole number 5 just a fraction? It's 5 over 1. If you took all the fractions in the world and you subtracted all the whole numbers in the world, wouldn't you still be left with an infinite number of things? So in this particular version of infinity, wasn't the answer infinite? Can you imagine I could create different stories with different infinities and get the answer 0? Ooh. I worked really hard at it. Take all the whole numbers in the world and subtract all the natural numbers in the world. Do you know the answer to that is 1? Because there's only one number in difference between the two. Right? So infinity is not a fixed thing. Here's a weirder one. Zero to the power of infinity. Oh, by the way, the answer to this is it's in determinant form. 0 to infinity.
Isn't that 0?
Yeah.
Would be. Corbin, would you think? You think
Yeah.
it's 0?
Definitely.
Definitely 0. Okay. So 0 to the power of anything. How about infinity to the power of 0?
1.
Okay. Let's see if we can work on this one. If I said to you 7 to the 0, 10 to the 0, a half to the power of 0, would you all agree the answer is 1? Okay. Now, suppose I went and changed the rules a little bit. Suppose I went and said to you infinity to the power of 2. Wouldn't the answer be infinity? Suppose I said infinity to the power of half, which by the way is just the square root of infinity. Would you agree the answer is still infinite? How about infinity to 1 over a tiny little number? Wouldn't that still be infinity? So couldn't infinity to the 0 still be infinity? Oh, can I make that number as close to 0 as I like and it still be infinite? You see the problem with infinities and zeros when they start interacting with each other? You will end up with a sore head. You'll just go, wow, you mean that isn't 1 and that might not be 0? They are in indeterminate form. It depends on which version of infinity and which version of 0. And you might say, wait a minute, there's only one version of 0. No, sorry about that. Would you agree as x goes to infinity, that's 0? Would you agree? As x tends to infinity, 1 over x is 0. Isn't 1 over x squared also going to be 0? Aren't both of those different versions of 0? We're putting limits here. 1 over x and 1 over x squared may both end up being 0 when x goes infinite, but don't they end up getting there differently? So even 0 isn't quite as fixed as you think it is. And infinity has never been fixed. but it should never have been fixed in your brain. Oh, infinity is just like 2 billion, you know, you just treat it like a number. That would never work, right? That would not be a good idea. And I think I've hurt your poor brain enough today, so say hi and bye-bye. We learned some cool stuff today. Especially at the end, when I started playing about with indeterminate forms. Corwin, what do you think infinity to the power of 1 over infinity is?
Wait. Infinity?
No. Indeterminate form.
Well, wouldn't 1
It-
over
it-
infinity be a positive infinitesimal 0?
Uh-huh.
And if you treat it like that, then it would just be infinity.
Well, infinity to the power of 0 or
If you
0
treat it
plus.
as if you treat it as a
Yeah, but
positive.
you have to treat both infinities and you could treat them differently. The first
Yeah.
infinity is not the same as the second. I know we write infinity, but couldn't one of them be whole numbers and the other be fractions?
Yeah.
And so, yeah, you are in a dangerous place whenever you see infinity, right? Just think danger, Will Robinson. You see an infinity, you think, okay, let's just take this guy slowly, just in case it's a sneaky one, right? Now, hopefully, you won't get any sneaky ones, but it's nice to know that they exist, right? That it could be out there in a different question that you've not thought about. It really freaked out a lot of early mathematicians when they started doing things with infinity. Because it came up with results that they just didn't like. You know, like infinity to the power of 0 depends on who infinity you're using and what 0 you're using. That does not work well with your psyche, right? Okay. Is there any questions, or I'll kick you off?
I just had the one with the homework last night.
Oh yeah,
Yeah.
we want to do that one. Let's do it right now then. What was the question?
So basically it was f of x equals 9 sine x plus 9 cosine of x. And then, you know, I got the intervals from between 0 to pi over 4, and then 5 pi over 4.
Oh, we're doing increasing, decreasing.
Yes, I just need,
Okay,
I didn't
gotcha,
quite
right,
get the
yeah.
local and maximum values. I was trying to,
And they worked out fine. So I don't need to do anything with them, or did they not work out fine?
for the local and the minimum values, I'm kind of confused, I guess, on that.
I'm just trying to figure out what your question is then,
Oh.
Skylar.
How to find like the local minimum value and the local min.
Oh, okay, right, gotcha. Right, so you've already said to me that you found the derivative. I'm just writing it down for my own benefit. And it looks
Yes.
something like that, right?
Yep.
And you solved it and you found out that there were, I believe there should be in the range 0 to 2 pi, there should be 2 places,
Yep.
right? Pi upon 4 was one of them.
And then 5 pi upon 4.
Right, and I'll put a half pi here, put 3/4 here, 5/4 there, 3/2 there, there 7/4. I'm just setting up, 7/4. Just setting up my little number line, and it's pi upon 4. The derivative is 0.
Yep.
And at 5/4 it's 0. And we do our derivative. And you did a test point in nothing. And I believe when you did a test point at 0, you got a positive answer, right? And then you picked something in here and you got a negative answer. And then you picked something over here and you got a positive answer. Is that what your number line looked like, or was
Yes,
that
yes.
what?
Yes.
Right, so we are almost there then. Right, let's look at pi upon 4, right? So it's kind of visual, but the way I do it is, okay, on this side, on the left, the derivative is positive. That means it was going up the way. Then it's 0. And then on the right-hand side, it's going down the way. So that tells me that at pi upon 4, I have a local maximum. Great.
Yeah. So I tried entering in pi upon 4 in the little max part, and it said it was wrong.
But that's not what you're being asked to do. That's maybe your mistake.
Oh,
They
boy.
don't want to know the x. They
Okay.
want to know the value of the function. They want to know that fella.
Okay.
So all you need to do then is find what the y coordinate is. You told us where the x is, but they ask you for the value. So when they say the local maximum value, or the value of the local max, or phrase like that, the value is the y coordinate. So it's going to be 9 times the sine of pi upon 4, right? The original function, this one,
Okay.
plus 9 cosines of pi upon 4. And that gets you 9 root 2 over 2's plus another 9 root 2 over 2's. So what's that get me? 18 2. So that ends up being just 9 root 2's. And at this one here, negative 0, positive, that's going to be a local min. And when you plug in 5/4 here and here, will you make sure that you notice that this is negative? So actually, I believe the second answer ends up having a y coordinate of 0.
Okay.